This is the Algebra 1 Summer School video, Unit 4, Lesson 5, Linear versus Exponential Models. This is the last lesson for Unit 4. Alright, so linear versus exponential models combines together Unit 3 and Unit 4 of our course so far. Alright, so a quick review is that a linear model is generally of the form y equals mx plus b, where m is our slope and b is our y-intercept. An exponential model is generally of the form y equals a times b to the x. Now it's important for us to compare the two models, linear and exponential, because in the real world, these are the most common types of modeling that are taking place for different scenarios. So we have to be able to understand how they work in order to understand problems and do well when we take things like the OST test. The two tables below in example 1 represent a linear function and an exponential function. Which is which? We're going to figure that out, and then we're going to write the equation of each. Now, in order to figure out if something's linear or exponential, we need to remember that linear has to do with adding and subtracting. And exponential functions have to do with multiplication. So I need to decide which table is dealing with adding and subtracting and which table is dealing with multiplication. So I'm going to look at the y values. I need to figure out how I'm getting from 5 to 10, how I'm getting from 10 to 20, 20 to 40, and so on and so on. Well, 5 to 10, if I was adding, that'd be 5 plus 5 gives me 10. But then 10 plus 10 gives me 20. That doesn't seem to be right, because remember when we talked about linear functions, we talked about how you have to add the same number every time, which is not the case here. So let's think about multiplication. Well, 5 times 2 gives me 10, and 10 times 2 gives me 20. So that looks like I'm going to be multiplying, which is an exponential function. And now I'm going to get to write the model. Y equals. The starting value is the y-intercept. Remember, the y-intercept always has x equal to 0. So if y equals 5 times our growth rate of 2 to the x. Now looking at table 2, we need to decide if we're adding or subtracting or multiplying. Well, to get from 8 to 11, I add 3. From 11 to 14, I also add 3. That seems to imply that this is a linear function. Well, linear function is in slope-intercept form. Y equals. Now, m is the slope. That's the number that we add every time. So it'd be 3x plus b. b is the y-intercept, which again is the y value that goes with x equals 0. So I have 3x plus 8 is the model. I have two more tables that are going to ask me the same thing. I have to decide if they're linear or exponential. Go ahead and pause the notes video, and when you come back, if you need help, I will have explained the two problems for you. Alright, hopefully you tried these two tables on your own. I'm going to look here and decide whether the first table on the left is linear or exponential. To me, it kind of seems like this is going to be an exponential function. It looks like when I go from 32 to 16, 16 to 8, there's nothing that I'm subtracting every time that's going to be constant between every number. So I need to figure out the growth rate. We talked in a couple lessons ago about how if I don't know the growth rate for an exponential function, I need to take the second number in the table, which is 16, and divide it by the first number. Well, 16 over 32 is 1/2. Now let's test and see if that makes sense. 32 times 1/2 is 16. 16 times 1/2 is 8. And 8 times 1/2 is 4. That seems to be correct. So 1/2 is our growth rate. When I look at my table, I can also identify that 8 is the starting value. So my equation is y equals 8 times 1/2 to the x. Alright, the last equation here. It appears that to get from 4 to 7, 7 to 10, 10 to 13, I'm going to be adding 3. Because I'm adding the same value every time, this is a linear function. I'm going to write this linear function in y equals mx plus b form. The slope is the number that we add each time that I have each time to get from one term to the next. So my slope here is 3. Then I put my x plus the y-intercept, which is 7. All right, let's now do a multiple choice kind of problem. The data shown in the table below represents either a linear or exponential function. Which of the equations below best models the data set? Well, it's going to be hard to decide at first because my first instinct would be to look for the y-intercept. But I don't have an x equals 0. I'm missing that spot right here on the table, so I can't eliminate anything yet. So what I have to do is first decide if it's linear or exponential, which will narrow down our choices. To get from 10 to 20, 20 to 40, 40 to 80, it looks like I'm multiplying by 2 every time. And I'm going to multiply. I think this is going to be an exponential function. So that means I can go to my multiple choice and I can cross off b and d because those are both linear equations. So my exponential function, because we're multiplying by 2, that means that my growth rate is going to be 2, which is actually the case for both options A and C. So I can't eliminate either of them yet. What I'm going to have to do is figure out what is the starting rate. Well, here's the trick. It's not 10 because the starting value has an x equal to 0, which is not on my table. So I actually need to go backwards a step and figure out what number do I multiply by 2 to get to 10. That value is 5. 5 is my starting value, which means that A is the equation for the table to the right. I'm going to flip your paper over. We have one more table that we're going to look at here. Same kind of situation, right? I don't have a y-intercept, but I have to start by figuring out what is happening to get from step to step. Okay? So let's try adding first, because the last one was exponential. 6 plus 12 gets me to 18. But 18 plus 12 is 30. That's definitely not 24, so this is not a linear expression. So just because of that, I know this is going to be an exponential function. So I can cross off b and d one more time. Now I need to figure out what I'm multiplying by to get from term to term. So I take the second number divided by the first number and get that the growth rate is 3. When I test that out, 6 times 3 is 18, 18 times 3 is 54, that seems correct. So I'm going to do the same thing I did in the previous problem. I need to find where x equals 0. What number do I multiply by 3 to get to 6? Well, that value is 2, which means that D is the correct answer to this. All right, let's look at the next one here. Given the following starting values and growth rates or slopes, let's write a linear and an exponential model that fits all those characteristics. So we're going to write both a linear and an exponential equation. So let's start with linear. We're given a starting value of 12 and a growth rate or slope, either way to talk about it, of 4. Well, linear model is always in y equals mx plus b form. So I have y equals. Now, if I have a slope of 4, that's the first number, right? mx, 4x, plus 12. That'd be my starting value of 12. An exponential model with the same characteristics would be y equals 12 times 4 to the x. Remember, exponential models are of the form y equals a times b to the x. So if starting value is 12 and the growth rate is 4, that's the exponential model I would have. All right, 2 more examples similar to this. A linear model that starts at 54 and has a slope of 0.5. Well, we'll have y equals 0.5x plus 54. That's my starting value, 54. An exponential model is going to be very similar, only it's going to be y equals a times b to the x. Y equals, the starting value is 54 times 0.5 to the x. Alright, finally, the last one of these kind of problems says that I have a starting value of 9 and a slope or a growth rate of 2. Right? So if I have a starting value of 9 for this slope-intercept form and a slope of 2. So I would write this as y equals 2x plus 9. A similar exponential model with the same kind of characteristics would be y equals 9 times 2 to the x. Alright, that's just a little bit of fun. playing around with characteristics and writing different equations. Our final example of the unit is given different equations, either linear or exponential, deciding what the y-intercept is and whether the function is increasing or decreasing. When I look at example 3, letter A, it's in the form 2 over 3x plus 6. This is linear. So when I'm looking at a linear function, the y-intercept is b, the constant that's by itself. That y-intercept here is 6. Now here's the tricky part. When I'm looking at a linear function, for increase or decrease, I'm looking for a positive or negative slope. It has nothing to do with whether the value is greater than 1 or less than 1. It has to do with positive or negative. Because 2/3 is positive, this is an increasing linear function. When I look at B, this is an exponential function because it's in the form y equals a times b to the x. The starting value, the y-intercept, is always the number in front of the parentheses, so it's 4 here. Now for an exponential function, I have to decide how 1/2 relates to 1. 1/2 is less than 1, which means this is a decreasing exponential function. For either of these, if you were unsure, I would take both of those equations and graph them in my calculator and see if they're going up or down from left to right. All right, in C, negative 2x plus 1. This is definitely linear. It's in y equals mx plus b form. The y-intercept is 1. But when I look here at the slope, my slope is negative 2, which means it's going to be a decreasing line. All right, finally, my last example. This is an exponential function, which means that my y-intercept is the first number in front, which is 5/4, and I have to look at the growth rate to determine if this is an increasing or decreasing exponential function. The growth rate of 3 is greater than 1, which means that it's an increasing exponential function. All right, you made it through all the notes for Unit 4. There's a set of practice lessons on campus. Go ahead and do that practice and check out the key in video if you have any questions.